All right, so good morning again, and welcome to this thermodynamics numerical from the book of Resnick Halliday. The chapter is thermodynamics. This is a very good numerical where you need to visualize the concept. Okay, let's read the question. The question is pertaining to the work done, and especially the positive, negative, or zero work. You can see my playlist of thermodynamics where I have given explanation of the positive work and negative work. It is very important for us to understand this. But the meaning of positive and negative or zero work in this question has changed a bit, especially the positive and negative, which is which is what makes this question very, very special. And let's read the question very carefully. So you have a gas, the initial state of the gas, and there is a vertical line, you know, through the dot that divides the PV diagram into regions 1 and 2. So let's see, you have a vertical line through the dot. So this is the vertical line, right? And it divides the region into 1 and region number 2. And in the case of the situation number 2 and 3, right? So these are three situations, 1, 2, and 3. And we have to see the the movement of the gas, you know, with respect to this dot. And it's very, conceptual. So therefore, pay a lot of attention to this question. The question is, what happens to the work as the gas moves, in each of the situation, left, right, etc., etc., right? Which means the left of the dot. So dot is important to understand, right? If you're moving towards the left of the dot, right of the dot, or if you are, for example, in this diagram, you're moving in this direction or this direction, right? So they have given this type of, so let's go through each of the part one by one and try to understand. So the initial state of the gas and the vertical line through the dot divides the PV diagram into regions 1 and 2. All right, so let's say uh, first case is the gas moves up along the vertical line. So this is a vertical line. The gas is moving up the vertical line, right? So the PV indicator diagram is this. So if you look into this situation, A, right? So we're talking about A, which means the gas is moving along the vertical line. If you move along the vertical line, your volume change is zero, right? Your volume change is zero because this is a constant volume, right? So you're just moving up, the pressure is increasing, the volume is not changing. And we know work done, if there is no change in volume, the work done is equal to zero. So this is a situation of zero work, right? This is the answer, zero work. So question is, in which situation is the work positive, negative, or zero? So A is a situation of positive, sorry, zero work. We've already established. Second, it moves down along the vertical line. Now the same situation, what you're doing is you're moving down. So let me just remove these uh, arrows so that it's easy for you to understand. I will just remove these and let's talk about this particular scenario. The movement this time is in a different direction altogether. The movement is here. Okay, so the gas is moving like this. Again, if you notice, if you're moving along this vertical line, this is the vertical line. The volume does not change, right? So even in B, it's a isochoric process, right? Constant volume. It's a constant volume. So the PV indicator diagram clearly shows that there is no area being covered. I hope you remember, if area gets covered, there is some work. So even this case, work done is zero because P delta V is equal to zero. Let's talk about situation number C. All right, it moves to anywhere in region 1. All right, so let's say this particular case, it moves to region number 1. If it moves to region number 1, do you see that the volume which is here, then the volume, becomes this. So the overall, if you see the gas movement, right, the volume reduces, it's leftward. So for C, situation number A, C, the gas moves from the dot towards region 1. This is what we are referring to. So the dot towards region 1, delta V is negative, right? So delta V is negative. I have told you, if you are moving leftward, you're compressing the gas. It is leftward movement, it is compression. The work done will be negative, right? Because it is P into minus delta V. Now let's talk about the fourth situation. Here the volume is moving towards the right, which means the delta V is positive. So D, right? Dot, and the gas is moving towards the right hand side. You get, this becomes 2. So delta V is positive. Therefore, the work done is positive, right? This is a case of expansion, which means the gas is expanding and doing work. The gas is doing the work. If you do work on the gas, it gets compressed, it's negative work. So for situation number 1, now you understand all the 4, right? When is the 0 work done? Let's talk about the B situation, right? Situation number B. If you look into the situation number B, I'm talking about situation number 2, and then we will go through each one of these. Obviously, I think there is no vertical line which is available, right? The gas moves up along the vertical line, we have already established. So here there is no vertical line in B. It was here, we have already done this. If you talk about this particular scenario, there are scenario number C and D, right? So the gas moves in the region 1. So let's say the gas moves like this, right? It is, if you notice, if you, instead of traversing this path, you follow this path in the region 1, and you go further lower, what is happening is your volume, for the same pressure. So for example, your pressure is this, and now your volume is this. But now, for the same pressure, your volume is reducing, right? So for the same pressure, the volume is further low. So you can see this pressure is same here, but the volumes are, the volume here initially here, then it is here. So this also is a leftward movement. So if you go towards region number 1 for the figure B, your answer is the work done is negative, because it's a case of compression. Again, be very careful about the concept. We're dealing with situation number C here, right? C, this is the answer to C for figure number 2. Be very careful as to how you approach this. Similarly, let's talk about the situation of when, the gas moves anywhere in region 2. So let's say the gas moves in region number 2, right? Let's look at this region number 2, right? So let's say the pressure of the gas is here, and for the same pressure, the volume is here. The second pressure, the volume is here. The third, the volume is here. So this is V1, V2, and V3. As you can see, the volume is moving towards the right, which means the gas is expanding in this situation, right? So if I were to answer what happens if the gas is moving towards in the region 2, it is expanding, right? Which means the situation number, figure number 3 is the case of positive work, because the gas is expanding. So the work is positive, right? So I hope you are able to make sense. It's a bit confusing because you're not able to correlate the diagrams with the questions, but this is my interpretation. This is the way you need to look at it. There is no mention whether it's a adiabatic process, it's an isothermal process. You just need to think through this question very carefully and see the areas and the points where the compression is happening or expansion is happening. That is what will decide the nature of the work. I wish the question was more clear and more clarity would have been given in the question. Since the clarity is missing, this is my understanding. And what I've done is I have applied the 1 A, B, C, D to all the situations here on the vertical line. Then I have applied situation number C here, and then I've applied the situation number D here, right? And that's the way I solved it, right? I was able to establish at least. So I hope this is making sense to you. Be very careful when you solve these questions pertaining to the type of work. The positive work, negative work, zero work are very important concepts to understand. This question is from Resnick Halliday, Thermodynamics. I hope the explanations are clear to you. The crux and the essence and the central idea of the question is clear to you. If it's a compression, it is negative work. If it's expansion, it is positive work. If volume doesn't change, it is zero work. So we had two situations of zero work when we were moving, down and up here. So that's a central idea you must carry, and the learning you must carry with this particular questions. I have 2000 videos on my physics channel. Please go through each one of them. Each of them is full of explanation. There is no website, no application, no classroom which is giving this level of explanation to strengthen your physics. My aim is to impact 1 million students in the country so that they have better future and they are able to build prosperity for their family. Follow my videos, subscribe to it so that you don't miss on any of the numerical. I can assure you, gradually your concepts will become very, very strong and you will be able to solve even the very complex numerical in a very simplistic manner. Thank you very much.